VORTEX video released by NASA from the Hubble Space Telescope of Comet ISON. This was released earlier this month, and it's a series of images actually recorded on May 8th by Hubble of the comet as it moves across the sky over a period of about 40 minutes or so. And as you can see, the comet's path is not a straight line. It actually forms a little bit of a curve, and this has caused confusion to some people. Some people wondering, A, if the comet's going the wrong direction, and B, if this path is indicating some sort of change in the comet's orbit, as Hubble's recording. So I'm going to go into a little bit of detail here about why it looks like that, and we'll try to see if we can find some answers. So the first thing to do is to, as always, look at the raw images. Now the raw images were actually not aligned on the stars, not where Hubble was tracking the stars as you see in the video, but Hubble was actually tracking the motion of the comet. And then in post-processing they aligned each of the individual frames back onto the stars. But if you look at the raw frames, what you can see here is that the telescope was tracking the comet, and the stars form streaks. And the stars form that same sine wave shape. It's more obvious when you align on the comet because the stars are just point-like light sources, and they form these nice little lines that tell you right away what the motion was of the celestial sphere relative to the comet, as seen by Hubble. Now, the question is, why is that happening? Normally, when you see time-lapse videos of Comet ISON shot from the ground, you expect to see the stars forming pretty much straight lines relative to the comet. But there's a reason why it looks like this, and the key to that is that we're dealing here with the Hubble Space Telescope, not a ground-based telescope. So what we can do is we can load up a program like Celestia, where we can simulate the view from Hubble, and you can actually download the orbital elements for Hubble from that time period. I'm going to put that into the video description. And you can also load up, of course, the elements for Comet ISON, and then see what it looks like when you track on Comet ISON as seen from Hubble on that date. So what I've done here is I've grabbed snapshots representing the time point from each of those 8 frames, as seen from Celestia, tracking it from the position of Hubble orbiting Earth, tracking ISON, just as we saw here. Now, of course, Celestia's database of stars is not nearly as comprehensive as what Hubble can actually see, so I've created an artificial star here to see what the general path of the stars should be in the image. I use the intersection of the right ascension grid to the declination grid at a specific set of coordinates to create this artificial star path. And if we combine those frames together into an individual frame, we can see the curve-like path of the star. Zoop, like that. That's the path it forms over the imaging time period that Hubble actually used. Now, of course, if we look back at the animation, we see that the path seems to be vertical, so this goes to the other question, is it going the wrong way? Well, we don't know what the image orientation is here just by glancing at it relative to the celestial sphere. We don't know that north actually means positive declination and horizontal is right ascension, or vice versa. We simply don't know what the image orientation is just by glancing at it. So we need to do a little bit more analysis. So we need an image of known orientation to compare it to. So I've gone ahead and grabbed an image from the Sloan Digital Sky Survey, SDSS, and astrometrically solved it. And you can see that it is in a normal image orientation where right ascension is horizontal, declination is vertical. And this is the same region of space that Hubble actually imaged. It's a little bit bigger than the region Hubble imaged. Hubble is a very, very narrow field telescope. But if I overlay that image onto the Hubble image, we can see, first of all, the image orientation here is exactly the same as it is over here. This is just a tighter crop. These 3 stars here are these 3 here. This bright star here is this one here, so on and so forth. And the angular difference between this image, which is true orientation on the right, and the Hubble image is 131.1 degrees, as it turns out. So if I rotate this image 131.1 degrees, it does nothing. That's magic. How did that happen? Ah, there we go. It took my first entry to be 0 degrees for some reason. And it'll act like it's locking up, but it'll finally fix it here. There we go. So now it's rotated at 131.1 degrees. And you can see the stars are now a perfect match between the SDSS image and the Hubble image. So that is the angular difference between the Hubble image and a true orientation where right ascension is horizontal, declination is vertical. So now, if we go back to our Celestia image, and we take an image from the animation that has, if we take all the images from the animation and combine them into a single frame, you can see that the stars form these trails. This shows you exactly what we saw, this trail the star's motion. And if we take out one of these stars and try to overlay it onto our virtual path of the star's motion as seen from Celestia, we know now that the angular difference is 131.1 degrees, so we can subtract out that angular difference, rotate, and see if it's a match. And indeed, it's a perfect match. The virtual star positions match up with the actual detected star positions perfectly. Now, of course, the actual Hubble images are long exposure photographs, so they form streaks over time versus snapshots from Celestia, but each of these dots corresponds to the beginning of each image, and it corresponds to the beginning of each trail. So, nope, turns out that ISON was moving exactly as it should have in the Hubble images. It's just that the Hubble images themselves are rotated relative to true north. And that's pretty much that. It's just an effect of parallax. This curve shape is actually because Hubble is orbiting Earth, and that induces a significant amount of parallax relative to the stars when looking at Comet ISON. But if you load it up in a program like Celestia, you can see it's quite normal. So I'll put the orbital elements formatted for Celestia in the video description, and you can download those and use them if you wish. Hope you have a nice day. Hi folks. Some of you may have previously seen this video released by NASA from the Hubble Space Telescope of Comet ISON. This was released earlier this month, and it's a series of images actually recorded on May 8th by Hubble of the comet as it moves across the sky over a period of about 40 minutes or so. And as you can see, the comet's path is not a straight line. It actually forms a little bit of a curve, and this has caused confusion to some people. Some people wondering, A, if the comet's going the wrong direction, and B, if this path is indicating some sort of change in the comet's orbit, as Hubble's recording. So I'm going to go into a little bit of detail here about why it looks like that, and we'll try to see if we can find some answers. So the first thing to do is to, as always, look at the raw images. Now the raw images were actually not aligned on the stars, not where Hubble was tracking the stars as you see in the video, but Hubble was actually tracking the motion of the comet. And then in post-processing they aligned